right. So, for anyone who's wondering, that song we just listened to was from Nier Automata, which sold about 5 million copies. So I'm a little bit surprised no one was able to guess it was from that game. Now, this next one I'm going to give you, the next 4 minutes, is really tough. You won't be able to guess what game this next song is from. But I encourage you to try. Let's take a listen. All right. Yes, so that one was pretty tough, right? That song, figuring out what game that was from. I'm pretty sure, and I might have to look this up, I'm pretty sure the real answer, and I'm not kidding you here, is Super Smash Bros. Ultimate, which features Sonic the Hedgehog as a character. So that would make a lot of sense to me. Okay, let's go ahead and get going here. We have a lot to cover today, and unfortunately, we say that this course tends to start up very quickly. It has a bit of a steep difficulty curve, and this second lecture tends to be a part of that. We have to introduce you to a lot of interesting and potentially a little bit tricky to wrap your head around concepts that are nonetheless very impactful. We have to get you this knowledge early before Project 1 starts because you'll be using it on Project 1. One of those topics is coroutines, kind of tricky topic if you haven't worked with kind of asynchronous programming before, and the topic of composition as a design approach / design pattern, okay? And how to build your games and build your entities out of a mixture of components. and how to make those components work well. It's kind of maybe a rival to inheritance as far as reusing code. So let's go ahead and get these announcements out of the way. I'll make my, my box a little bit smaller here. If you're pulling an all-nighter on tutorial 1 and tutorial 2, yeah, that's not good, okay? That's not very good, and something has gone wrong. It's up to you to identify what that was. You know, sometimes you get super unlucky, like you have a hardware issue, or you get sick, or a family emergency. Totally understandable. But ask yourself, you know, if you spent all night or went to like 2 or 3 a.m. finishing up these first few assignments, you might want to ask yourself, is it a scheduling thing? Like, did I just start late? Is it procrastination? Come to office hours. There are a lot of techniques that we can tell you about to help get past procrastination, to help get an early start on projects, to get help early when you run into a big blocker, right? If you do that early enough, we can generate ideas, we can help you get past those blockers in time to submit without having to go all night. It's not healthy when you do that, so you want to get past that as soon as possible, okay? Don't want to do that in Project 1 too much if you can help it. By the way, I want to get some feedback from chat. What did you think of Tutorial 1, Tutorial 2? Does anyone want to admit that they went a little bit late on these assignments? Yes, you do have access to this Lecture 2 doc. I posted it ahead of time since there aren't really any spoilers in this particular lecture. There aren't any good things like lecture surprises that I sometimes put in. So you can click on, you go to the schedule, which you can get to from the main Canvas homepage. You can click right there if you want to get access to this and kind of read along with us today. I spent way too long in tutorial 1 because my ball kept falling through the plane. Yeah, that suggests a rigid body or collider issue. We'll be talking about collisions today, actually. It was pretty fun and chill. Kind of mini projects, definitely kind of fun. Tutorial 1 was harder than I thought. Yeah, certainly can be. Woke up today and realized it was already the 25th. Time flies, doesn't it? Tutorial 1 took longer. Tutorial 2 went faster than expected. Gotcha. Yeah, it's always, it varies a lot among students. Which ones are faster, which ones are slower. What we planned, the all-nighter, as part of our schedule, you should not do that. You should not plan on all-nighters. You need to, over the course, if you find yourself pulling all-nighters, you need to ask yourself why that is. And you need to ask yourself whether there are some things that you can try out that might help you not have to do that. Starting a project early. And okay, here's a technique for you. I don't think I talked about this in the first lecture, and this is a technique that took me a while to discover myself. When you get blocked by something, it is often a matter of personal pride that we push and we push and we bang our head against that wall until we knock that problem down, right? It doesn't matter if we spent 2 hours, 3 hours, 4 hours on the tiny problem that's blocking us, right? We just got to get it solved, right? In reality, that's not a good thing to do, okay? In this course, by design, you do not have a ton of time to spare. And this forces you to think more carefully about your time and where it goes, how your time gets allocated to solving certain problems and how you spend it. So here's the technique. When you get blocked by something, you set a timer in your head or maybe even physically on your wrist or in a browser. You open up a timer window and you give yourself 20 minutes to solve that blocking issue, to find some way to progress a little bit. But if you spend 15 minutes, if that timer goes off and you've made zero progress and you have no idea on something to even try to get past it, that is when you must go to Piazza right away. You go to Piazza and you post the question, okay? Hey, I'm blocked by this. I don't know what to do. I have no idea how to, I tried these things, but I made no progress. I have no idea what to do. Here's what I'm seeing. Here's the error message I've got. When you understand this, when you post that, you can then move on to working on something else. You're probably not blocked on all the things you could be working on. And so what happens is you post to Piazza, you now have like 10, 20, 30 people, several of them instructors, now thinking about your problem with you, okay? And when an idea comes to their head, they'll post their idea, and then you have an idea to work on, right? It's kind of about multitasking. If you're in 482, you can think of it this way. If one thread gets blocked, you want to launch another thread that's just kind of waiting in the background, just kind of thinking about ideas and go, move to something else, okay? You don't want to sit there blocked. You want to offload some of that work to other processors who might be able to come up with a result for you and unblock you. That's being efficient. If you run into a super, super nasty challenge that you just can't get past at all, what you want to do is you want to collect that in a list and then take it to office hours. You can spend 4 of your own hours knocking that problem down. But if you take it to office hours, that same problem might only cost you about 30 minutes, right? And that's a huge time savings. You just won yourself 3.5 hours to spend on something else. And you're going to need that time. You're going to need it to get through this course, okay? And so consider these techniques, okay? If you get blocked by something, give it 15 minutes, no more, then go to Piazza. If you're still blocked, then put it on your office hours list, go to office hours, and then knock it down as efficiently as possible, okay? That's what I recommend. You'll save a lot of time that way, a lot of headaches, and you'll get a lot more sleep if you use these techniques in a disciplined fashion. And no shame at all. We get blocked. Asking for help is something that really productive people, right, in an org, in the company you go to, your research group, are going to be those who know when to ask for help and know who to ask for help, okay? Let me give you one more story before we fall even further behind. During my first few weeks at Electronic Arts, I was just jumping onto the Sims 4 codebase. It was kind of toward the end of development. They've been working on this game for about 4 years at the time. I think the project had like 4 or 5 million lines of code at that point. And I was under the impression that what you were supposed to do when you joined a team, well, right, when you became a professional software engineer, was you were supposed to go into a code base, you're supposed to immerse yourself in it, you're supposed to study it and understand it so you can be productive, right? You're supposed to be a rugged individual, just going into that code base and knocking it out yourself, right? Have some pride. Don't eat anyone else's time by asking silly questions. In reality, it's not how it works. In reality, when you have a big code base, you have a lot of different people who all are experts in their own systems that they kind of manage and own. And if you need to go solve a bug in one of those systems, then your first order of business is not to just dive into that system. It's to go and find the person who owns that system, talk with them a little bit about the bug you're seeing, and then get their advice on what you should look at first. And then if you don't understand how their system works, you then ask for their documentation and you ask them some Q&A, right, to figure out what they were thinking when they made it and what their pain points are when they maintain it. And so that is what ended up happening. If you go to a big game team, it becomes an extremely social exercise, right? If you run into a bug and you get blocked for 15 minutes, you immediately go, okay, I need some help. Who's the person who's going to know how to help me? Right? The best chance of helping me. You find that person, and if you're lucky, they'll say, oh, yeah, that bug. Oh, yeah, I've known about that for a while. Why don't you give that bug to me so I can solve it quickly? Or they'll tell you how you should think about solving it really fast. It expedites you, right? What could be like a no-joke 5 or 6 hour bug can turn into like a 10-minute thing. If you talk to the right person, if you get the right insight at the right time. And so don't be afraid to reach out, okay? Productive and healthy teams do this all the time. And if you think about it, in 494, we really are kind of on a team. We don't compete for the A's. There's not a limited number of A's in this course. We want our peers to be healthy and moving quickly and be productive in their understanding because in a few weeks, they're going to be on our team, okay? So the better our peers are doing, the better we're going to do. So anyway, this has been a huge tangent. I always like telling stories like this. I hope I apologize if it bored any of you. Any comments here? The hints were really helpful for both tutorials. I want to thank all of you. We had a ton of people giving feedback on the Tutorial 1, Tutorial 2 assignments. I would encourage you to do this for every assignment because, as you just said, the hints, right? The hints are very helpful for moving you in the right direction so you know basically what to look into, what to research, and what to use for Tutorial 1, Tutorial 2. Those didn't used to be there. those kind of things get into an assignment when enough people make that kind of suggestion, or enough people say, like, I lost a lot of time because I was barking up the wrong tree. Well, we don't want you to do that in this course. You don't have that much time. So we decide to kind of direct you and kind of nudge you in the right direction, which is something you'll actually find in a lot of great game design as well. In fact, we have an entire day on this topic. It's called guidance, as far as industry terminology goes. Anyway, we'll get to game design stuff in a couple weeks. It's a very, very fun topic. Okay, so let's go ahead and get going. Some motivation to begin the week. I like this image quite a lot. It says, be like a duck. Above the surface, you want to look composed and unruffled, and you want to keep things together. But understand that below the surface, you need to work a lot, right? And you do that. In fact, if you think about the people, like, okay, the students running your local clubs that you go to, the people you respect in research groups or at orgs, right? Very often, they are doing a ton of stuff, and they're managing a lot of stress, and they're managing a lot of very difficult challenges. But their ability to cope with that is something to be admired, right? So this is to say that you want to think about your time management skills. You're doing a ton of stuff under the surface, but you're managing it pretty well, and as a result, you're staying healthy, which makes you allows you to take on more stuff, which makes you more impactful, which builds relationships, which builds portfolios, which builds your time management skills, which lets you take on more. It becomes a positive cycle, right? Until eventually you're doing a lot of stuff and having a lot of positive impact on a lot of people, and you're all going to get there. You're Michigan students, right? It is not an exaggeration to say many of you will be running your own teams sooner than you think when you go into industry or academia. So it's time to start thinking about your time management if you haven't. Okay, very, very fun thing to experiment with. Graduate students, please contact the undergrad advising office, UJ-Admin at eeks.umis.edu if you haven't already. 494 rarely fills its seats due to its difficulty. We always get some drops, and so you can almost always get a seat if you want to, but please consider that this course was designed for undergrads, and the work schedule might not fit your graduate schedule, okay? So please consider that, and ask me if you have any questions. Don't be afraid to reach out. Some tips for submission. The syllabus has these. I think I've pulled them up here as well. When you submit something, you typically want to re-download your submission from Canvas just to verify that the thing you uploaded is the thing you thought. Oftentimes, students will create multiple builds in submission files. They'll give them similar names, unfortunately, or they'll have many submissions, but they'll be in the same folder. What can happen is when you go to upload to Canvas, you click on the wrong zip file to upload, and you don't think to check, right? And you don't notice that the naming is slightly off or something like that. What happens is a few days later, when there's no longer any submission allowed, your grader goes to download it and says, oh, you submitted tutorial 1 for tutorial 2, in tutorial 1 for tutorial 1, so you never gave us a tutorial 2 on time, which means there's a 0 for that assignment. It's not good, okay? Don't do that. Re-download your stuff. Make sure you submitted what you think you did, and make sure it runs, okay? A 20% penalty if turned in under 24 hours late. That is the late policy in this course. It's very simple. Though, yeah, it is nice in that it's simple and easy to understand. It can be a little bit nasty if you're not used to turning stuff in pretty promptly. So turn stuff in. It's a 100% penalty if it's turned in 24 hours or more late, and Canvas is the final decider here. The timestamp is what we consider. Here's the technique to use to get past this. Always upload a safety build, a safety submit, like 24 hours early, okay? It doesn't need to be done. It doesn't need to be anything. Submitting something will get you some points in almost all cases, and that's way, way better than getting a 0. It's astoundingly better. So we can resubmit as many times. That's correct. You can submit any assignment as many times as you want. Yeah. So make sure you get that safety save submit in, okay? We'll have some more techniques to talk about when it comes to submitting as part of a team, but that's going to be for a little bit. The toughest stretch of the course begins in 2 days, so take this opportunity to rest up a little bit, mentally prepare yourself, Again, if you can make it to the end of the project 1, then you're at a very good place. Okay, and that actually is, when is that? End of project 1. The P1 postmortem begins on in the middle of February. Okay, so it's only the 15th. That's not that far away. Can you make it? I think you can. We'll help you. Okay, some assignments released. Not really, but you need to fill out this form, a reminder, by Wednesday. Okay, you need to fill this out if you want to specify and control your own team composition. Otherwise, we're gonna create a random team, and we're gonna hope that goes well. Okay. In this course, not so much on Project 1, but in this course and in life, creating and managing your roster, like deciding who you team up with, what business you join, what research group you join in academia, is like one of the most important things you can possibly do. For P1, it's really hard because you don't know anyone, and like no one has a portfolio to check out, but you do want to take this seriously, particularly on P3, okay? Okay, and this is basically the reason that I created my startup. I really wanted to be able to control the people I worked with, and it has been very, very nice being able to do that so far. Okay, I'm not going to show you that yet. Okay, I want to show you a few things. We always like to talk a little bit about a game design concept every single lecture. I like to show you an actual game since this is a game dev class. Shadows and platformers. So one thing that always happens on tutorial 1, the rollerball game, is the default that the tutorial takes you through does nothing to adjust how the directional lighting works in that game. As a result, what you often have is platforming that's surprisingly difficult and not in a way that feels satisfying or good. So let me give you an example. In platformers, the shadow is extremely important. Humans are really good at judging depth perception, IRL, because they have 2 eyes, right, that can be used to judge depth in a 3D world. Unfortunately, when it comes to a screen is only capable of showing 2D images. And so the brain has to use other cues to figure out how deep something is. And so if you look here, it's very obvious where the ball is in 3D space because there's a shadow, right? If this shadow were off to the corner or the side when you jumped, it wouldn't be as helpful. And this is what most of your tutorial 1s have, because the shadow moves off away when you jump, right? The shadow is an indicator of where you are on the Z kind of axis, the XZ plane, at any moment in the game. And so it's very, very helpful when it comes to jumping. Well, like this, it's much easier to tell where you are over these gaps, and there's a bit of lag on my controls. I'm going to blame lag for that one, chat. Anyway, you can trust me, right? So anyway, I want to show you what it's like to, is the stream stuck? I hope not. It looks like it's fine. I'm going to turn off the shadows here, and look at how nasty the platforming is with the shadows off. Okay, you can sort of tell where the ball is because it's always the center of the screen, right? You come down to the center of the screen, but then no, it doesn't. It's a little bit dicey, right? It's a little bit hard to understand exactly where you are in 3D space because there's no visual indicator of where you are depth-wise. With shadows, it's just a lot easier. It doesn't hurt your brain as much, and you can just kind of calmly and carefully move, and you know when you're over a platform because that shadow gives you a hint. And okay, I'm going to blame the lag again. But anyway, this is so important in 3D platformers, right? Helping the player with visuals understand where they are. That AAA games will do some crazy things. They'll go to crazy lengths to help you understand where you are in 3D space. I'm going to show you a modern, some of you are going to laugh at my description of that, a modern 3D platformer, Crash Bandicoot Insane Trilogy, and I'm going to show you a level from that. What I want you to do, chat, is I want you to look at the shadows in use in this game. I want you to study the shadows and how they work, because you're going to notice something crazy if you look carefully at the shadows, okay? Something that shouldn't make any sense at all. So let's go ahead and watch this. This is a level called Boulders, where you're running from a famous level, where you're running from the you're running toward the camera. Okay? Watch the shadows. What do you notice about the shadows? Do you notice anything, chat? Did you notice anything? So what did you notice? Yes, that's right. So your shadow always goes down, right? And the environment, however, has much more realistic shadows that are angled because there's a sun and it's not overhead. So they're cheating, essentially. The designers decided, and actually it goes even crazier. It's even crazier than this, because if you look very closely, you'll notice something. Can I get it? Ah, there it is. There it is. It's hard to see, but you can see it. Okay, do you see this line right here? Okay, that is Crash's arm. Do you see this kind of dark spot underneath Crash, though? That is not his shadow. That's not an accurate depiction of his shadow. If you watch this clip, you can see that the main character actually has two shadows in this game. One of them actually bends and morphs. If you go to a hill, you'll see that it kind of bends down the hill. You have a realistic shadow in this game because they wanted it to be beautiful in AAA and they wanted it to be realistic, but you also have a second shadow that is a fake shadow. It always goes down. It is always a circle no matter what the shape of your character is. And so you can see that the designers wanted to have realistic shadows, but it was so important to them that the player always understand their kind of ZX position on the map for platforming purposes, that they created a second shadow. I guess that implies there are two suns in this universe, but I don't think we should read that far into it. If you don't believe me, the lengths to which they went to make sure you understood where you were in 3D space. Here's a question for you. Have you ever seen a shadow be cast on thin air? The answer is probably no, but in this game, the answer is yes. Watch this. Did you see that? Did you see that? Do you see that right there? Chat, are you seeing this? The stream's a bit choppy. Let me go ahead and hopefully we'll be able to, it's fine, it keeps going in and out. Yeah, it seems like it might be some individuals' connections. Okay, so hopefully it's fine now. But everyone, do you see this right here, right? This is a shadow being cast on nothing, okay? Because they really, really needed you to be able to understand where you were when making these really precise jumps on this stage. I think they tried to put some like cloud and fog in here to maybe make it plausible that a shadow could land. But in reality, yeah, it's just very transparent what the designers were trying to do here, okay? And then you see the realistic shadow come in when you get back to Solid Land. Yeah, it's pretty funny stuff, but very clever. Players essentially never complain about this unrealistic feature, but it works really, really well for helping them platform. So anyway, the most modern example of this, Crash Bandicoot 4, could be considered the sequel to that game. They went just overboard, and they said, you know what? We're just going to draw when you jump. Look at this. Whenever you jump at all, the game starts drawing a yellow line, even on top of nothing. A yellow circle on top of nothing to make sure that you understand where you are. They're that serious about it. Okay, so anyway, the takeaway here is that if you watch closely, there are a ton of little things that game designers will do. The trade-off between realism and playability is something that is, is a big topic of contention in design rooms. And it's very interesting to see the trade-offs that designers will make to make sure that a game is playable, but also very realistic and immersive as well. Okay, so let's go ahead and get into the, you might consider the meat of this lecture, course logistics. It's something that we skipped on our first day, but something that is very, very important. But not important enough to do on the first day. All right. Has anyone seen this clip before? It's a classic. Let's go ahead and watch it.
What's his name? What's his name? I got nothing on a name. Come on, baby. What's the name? We threw out his name!
All right. SpongeBob, very, very relevant. That's an example of logistics gone poorly. And so let's go ahead and make sure this doesn't happen in 494. Let's talk a little bit about some of the specifics of this course. So date and time, you already kind of know this. It's 12:30 to 2:30 p.m. Eastern Time. And then there's another section from 2:30 to 4:30 p.m. So if you want to hang around for that, you can. You can go to either of these if you want to. However, all assignments are due at the start of the first section, okay? I apologize for this timing. I don't think, I don't know that I have the ability to change it. If you're in the Southeast Asia region, this might be pretty late for you, and I apologize. We do this on twitch.tv. Standard lectures tend to fall into certain categories. We often go over the history of different game development topics, theory, discussions, and we also share stories. During a workshop-style lecture, what we'll often do is we'll dive into the implementation details of how to build a certain system. We'll do demonstrations of systems from other games. We'll go into how things work at a low level, and we'll talk about technology. I often get an interesting split of students that kind of prefer this kind of lecture to this kind of lecture, and we have students who really like jumping into the nitty-gritty details of how to program an effective system. We'll split these pretty evenly. You'll get a lot of examples of both, but later on in the course, we'll also have quite a few lectures dedicated to playtesting. This is essentially going to be a period carved out for you where you're expected to go and play test a lot of other games, your peer games, usually between 5 and 10 of them. And you will be recording yourself, kind of like a Let's Player or a Twitch streamer, playing these games and offering specific and actionable feedback as you play through them, right? Making recommendations. And then all that data goes to the development team to the point where, as a development team, you will receive around 4 to 5 hours of playtesting video from your peers every single week, okay? And that's really helpful for making your game polished and making it effective at what you're trying to accomplish, okay? We then have another type of lecture, which is the guest lecture. Q&A, it tends to be very visceral and very interesting and enjoyable. We had I believe last semester we had the former Atari vice president, John Hayas, Skype with us, and that was really interesting. You get a lot of insight from the industry professionals that way. And then we have unfortunately, we have a final lecture type, and I'll just spoil it for you. It was field trips. One of my biggest source of sadness from this pandemic situation has been we can't take you to Pinball Pete's, which we always did, give you a few quarters to play some games, study how arcade games differ from home console games. And we can't take you to Ann Arbor Spark, where we used to have former students and local business leaders talk to you about how they use game dev technologies locally and for humanitarian reasons. So I'm very sorry. If you want to join us, though, when in-person semester begins, maybe you can audit during that day and join us for the field trips. That'd be pretty fun. You get to see me play DDR. It's not a pretty sight, I'll tell you that. Okay, a reminder on the schedule. The first part of this is mostly dedicated to engineering concepts. We then move into design, right? How do you make a game? Then how do you make a game that is engaging? And then we try and combine the two and introduce scalability in the final part of the semester. Okay? So let's talk about grading and policies. This course, I calculated it last night, has about 872 points in it. That's not counting extra credit. We have a lot of extra credit in this course. So if you had a bad submission on Tutorial 1, Tutorial 2, okay, just put it out of your mind, all right? Focus on the task ahead because there's going to be quite a bit of extra credit for you to get some of those points back. So a point, how valuable is a point? It's around 0.1%. And what are the values of these assignments? Well, your Tutorial 1 and Tutorial 2 are both pretty substantial. They're pretty loaded up with points, and part of that is to make the grading overall a little bit easier on you in this course. The average grade in this course is, in fact, an A. It's a low A, it's a high A minus. And so as so long as you get the time investment in that you need to, there's a very good chance, and so long as you listen to feedback, there's a very good chance you're going to get a very good grade in this course. It's not the kind of thing where an exam shows up and just knocks away all the points you scored from your project grades. That happened to me a lot. Is anyone in here? Like you do really, really well in the projects, and an exam shows up and just boom knocks you down? That was me a lot. So very happy we don't have exams in this course. If you get the time in, if you invest the time and you invest it smartly, and you follow the feedback you're given and advice, you're gonna be okay. That happens. That's why my GPA stinks. Of course, yeah, it happens a lot. Yeah, I still remember. Gosh, I have too many stories, but I still remember 281 when I took it had a multiple choice exam. And one of those exams I was not very prepared for. And it was like 20 multiple choice questions. And I remember I had to guess on 10 of them. 10 of them. That's not good news, right? I got every single guess correct. I got 100% on that exam. And I had to guess half the questions. Most lucky I've ever been in my life. Anyway, okay. From then on, I actually studied it and knocked the exams out pretty well after that. But okay, Project 1, 170 points, 19% of your grade. Project 2 is a little bit less than that, but still very substantial at 150 points, 17% of your grade. But the big majority of your points in this course is going to come from Project 3. It is the longest project by far, and it has many sub-assignments in it. So it's not a huge thing you need to worry about because it has many sub-assignments. So you can recover. If you struggle early, you can always recover. But it is something you really need to think about. Participation is about 3% of your grade, unless it goes negative. Okay, in this course, your participation grade can in fact go negative, and usually that almost always happens only if you run into problems with your team contribution. In this course, we track the hours you invest in your project, and if that is substantially less than the average of your team, then you're going to get wrecked. You're going to lose 50% or 25% of the total points your team earned on that entire project. That is to say, you need to be contributing at a semi-similar level to that of your teammates, okay? You don't need to be exact. You don't need to be particularly close, but if you're substantially off, then you're going to get, we're going to find out, okay? Every single semester, we dole out about 5 to 10 of those big 50% penalties, so be careful. Many opportunities for extra credit. This doesn't affect your curve. The average grade in this course is about an A-A. I had someone asked why it was 872 total points instead of 1,000. The reason that's the case is because that is, we didn't really care about the round number. It looks nice, but it doesn't hugely impact the grade. These ratios, in terms of project importance, make sense. And with extra credit moved in, we think the point allocation works out very well for this course. So that's the reason why it is. Grading process. Games tend to be a little bit subjective, right? We all bring different biases into what games and what genres we understand. And so what happens is on the larger assignments, what'll happen is we actually grade them as a team. You've got 4 graders, 4 people who are capable of grading in this course. And so we actually kind of debate and our opinions get averaged, and that's how we decide what your grade is for that particular deliverable, okay? Okay, collaboration policy. For T1 and T2 and Project 1, so for this early part of the course, you are not allowed to use external assets unless they're given to you or you're prompted to go get them from the internet. You're not allowed to copy any assets from other teams, and you're not allowed to share any code with other teams. Okay, we do check this via MIT software, and just about every single year we get a team or two, and they get wrecked. So don't do that. Okay, you're really putting yourself at a disadvantage as you move on to the tougher projects, Project 3 and 2 as well. However, for Project 2 and 3, since everyone is working on a different game, sharing and discussing code is a much more doable thing. It's not nearly as strict when it gets to that. So just take it easy on these first few projects. External assets are allowed on the other projects, but you need to always credit whatever stuff you use. Okay, you can't put something in your game that you didn't make and not tell us that you didn't make it. Usually this comes in the form of a credits.txt file that you just throw into your project folder, and then you're good. Okay, we find it, we see what you didn't make, we're all good. You're going to want to check each assignment spec for explicit rules, because some of them are ban certain things. And then code copying, yeah, blah, 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 blah. Okay, you got it. Some questions. Can you move Facecam up so we can see the full box? Yes, but I'll probably have to move it down pretty quickly. Whee, there we go. Any other questions? I got all the M's here. Okay, Slacker's getting punished. Yes. Though, keep in mind, it's not always... The reasons you might not be able to contribute to your team, it's not always because you're lazy or you're slacking, right? It can be a family thing. It can be just, hey, your situation is really not good right now. It could be a health thing. The important thing is that you make contact with us and you let us know when those things happen so that we can understand, oh, this is not a case of you slacking, okay? The penalties should not be applied. Your teammates will appreciate it, right? They'll be able to cover for you, and then maybe you can pay them back in the future. It's not always a case of slacking, but you need to have good communication, okay? So here's some things. You may discuss general course concepts at any time. You can always discuss assignments at a high level. And you can always share code with each other for implementing general concepts. If you and a teammate and a friend are struggling, if you and someone else on a different team are struggling with a certain concept, like you don't understand raycasting or how to use it effectively, then why don't you create like your own pet project that isn't related to any other assignment, and it's just an experiment you are doing with your friend over there, and you just see what happens, right? Totally fine. Just don't share assignment-specific code or assets or anything like that, okay? You may not share project-specific code. You may use external assets such as code, art, music, etc., but generally we want this to be done in small quantities. Don't download a project from the internet. We're going to notice, we see those a lot. Only if most of your project assets were created by you, and only if you document your usage. So you need to have a credits.txt, you need to say what you didn't use and where you got it. And you need to also check the license for that asset. Do not go putting in a PNG or a JPEG of Mario from Google Image Search into your project. That's going to get you in trouble. Not in huge trouble, because we'll just see it and we'll tell you to take it out for the next submission, and we'll penalize you if you don't. But you need to care about licenses in this course and also in life, okay? So what is a license? Well, if you go to most GitHub repositories, here's an example of the Godot game engine. What you'll find is that there's usually a license.txt or a license file somewhere in that repository. That license is essentially a block of text that tells you what can you do with this software. Can you just take it and do anything with it? Can you take it and do anything with it, but you can't sell it? Can you take it and do anything with it, but any changes you make, you have to make public? That's the GPL. That license scares the bejesus out of any company if they see it. Licenses are things that you need to care about, and even in this course. In general, you can use anything that is open source or permissibly licensed. You cannot use something that would get you in trouble for posting it on the internet. Do not take an image of Mario and put him into your game. The only exception we'll make for this is the Project 1, which has you recreating Zelda or Metroid. You don't have to care about licenses there. But here's an example, OpenCV. You go to their website, it says, hey, it's released under the BSD license. which is very permissive, if I recall. It allows you to do almost anything you want with the code base. What else we got? Open source initiative, approved licenses. Blah, blah, blah. If you go to opengameart.org, which is a great place to get assets, music, code for your game, 3D models, objects, what you'll do is you'll go to an asset, you'll like it. I love the sound file. You'll play it, and then on the left, you'll see, hey, there's a license for it. It's public domain, CC0. If you click on it, it'll actually tell you more about what this license means. In this case, it means you can do anything with this. Like, you don't even need to credit. You do need to tell us, that you didn't make it, but you don't need to even credit in your game this asset. You can just go use it. Okay, participation. Must I attend every lecture? Yes. Wait a second. No, because this is a COVID semester and our policies are adjusted for it. Must I attend every lecture on time? No, you can watch recordings if you want to. There are certain lectures where you must actually do something with a time limit. Those are usually playtesting sessions because you need to get feedback to your peers quickly, otherwise they can't use your feedback for the next submission. Why should I care? There's a 20-point penalty. That doesn't really apply to you, though. When is attendance taken? Blah, 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 blah. This is all kind of not so useful for you. Blah, 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 blah. In general, in this course, if something prevents you from meeting an expectation, for instance, you have a family member who's sick, or you have an illness yourself, or you're having like horrendous internet issues where you live and you have to drive like 2 hours to get to the nearest Starbucks to upload your stuff. Like, let us know about that stuff. If something isn't in your control, is it really fair to hold you the same expectations? Sometimes, but sometimes not, okay? So please contact us, okay? In fact, that is the golden rule of this entire course. But anyway, lecture capture, when are things due? Typically beginning of lecture. Okay, late policy. Okay, here's the golden rule for this course. I think we'll get to it later, but you must communicate with us, all right? If you ever have a question about something, go to Piazza, go to Discord, send an email to us at eeks494staff@umich.edu. Communicate, because we can't help you through the problem if we don't know about it, and it might be too late, okay? So you got to communicate early with us as soon as you can. Let's talk about the late policy. It's very, very simple. Here's some Python code to implement it. If you are less than 0 hours late, as in if you're not late at all, then we just return the graded assignment score. If you're less than 24 hours late, then you get 20% off. It's a 20% off sale, all right? You want to avoid those. Not good. And if you're 24 hours or more late, we're just not going to grade it, okay? There are no exceptions to this unless something outside of your control happened. So please get your stuff in, even if it's incomplete, okay? What's the official timekeeper? It is Canvas, okay? And note, if Canvas says that if something is due at 12:30 p.m. EST and we see a submission timestamp of 12:30 p.m. EST, Canvas is going to mark that as late. That's late in our books too, okay? So get it in early, all right? Not when it says the exact time of due date, that is considered late, okay? So please get it in. What if Canvas is down? We're going to excuse that only if it's a widespread outage. So you have a lot of opportunity to submit things early, late, all day. So do submit stuff, okay? Submit stuff early. Submit often. Resources. Check Canvas. You have a lot of office hours in this course, and very few people use them. So please use them. Here's the chain of help. Here's your process. You run into a nasty issue. You've got 15 minutes, spend it Googling and experimenting. If you make no progress at all and you have no more ideas on what to do, you post to Piazza right away, okay? That creates another thread that is actively working on unblocking you while you go work on something else. If you still can't get that thing solved, right, you start working on another issue. If you still can't get it solved, you queue it up for office hours, okay, where we can hopefully knock it down pretty quickly or get some other means of getting past the issue, all right? Private correspondence, email us, eeks494staff@umich.edu, Piazza, or Discord. For community tutoring, if office hours aren't enough for you, there are actually big orgs on campus and groups that are full of other students who are really experienced and really well versed in Unity, in game design principles, and stuff like that, don't be afraid to ask them some general or high-level conceptual questions, okay? Like, how do I tackle this kind of high-level problem in Unity? Take it to Wolverinesoft. There are really experienced people there who will give you great suggestions. We don't have EECS 494 Public Game Night, sadly, anymore. You can also come to IGDA Ann Arbor if you wish to get help there. Health. If you're ever feeling down in this course, if you're ever feeling depressed, if you're ever feeling like you don't have any energy, organizations like CAPS on campus can help you out. We can also help you out as well. So don't be afraid to come to us and kind of explain, what's going on. Managing your mental health and your physical health is an important part of being able to do a lot of productive things and be impactful and help other people. So we want to help you manage your health. So come to us. We've got techniques for you. We can help you rest easy, put your mind at ease. So contact us if you're ever feeling down, okay? And EECS rule number 1, you've got to communicate, okay? We cannot help you get past problems and struggles if we don't know about them. So don't be shy and don't have pride on this topic. Reach out early and be disciplined, okay? And we can help you. We can't solve problems that we don't know about, so help us out, okay? And that's that. Does anyone have any questions on the logistics? I felt like we moved a little bit slowly through this, so chances are we're not going to get through everything this lecture. We'll pick it up on Wednesday and finish it up, okay? What are rules for sound assets that have been manipulated? Your Discord office hours link on campus has expired and isn't working anymore. Ish, can you go ahead and fix that? Yes. Okay, so it might look expired if you're already in the server, maybe. What are rules for sound assets that have been manipulated? Look at the license. The license usually, most licenses on opengameart.org will let you manipulate sound. And if that's the case, then fine. What you would do is you would manipulate the sound, like throw it in Audacity, manipulate it, and then in credits.txt you would say, we use this external sound. Okay? That's all you would really need to do. It's pretty awful. Resolving Git conflicts. Yes, for Project 1, you probably want to use Unity Collaborate, and this is something we'll talk about on Wednesday as Project 1 begins. Okay? Git and Unity are not the best of friends at times, and so certain techniques should be used to minimize the risk of you having merge conflicts. One example of this is you typically want to make sure that you're working on different prefabs, and you want to make sure every person has their own scene that is just dedicated to them so that they can run experiments in their scene without trashing anyone else's and without trashing the main scene, who will be managed by a dedicated person who does integration of stuff. Do we need to place the credits text in the assets folder? You can put it there, but I recommend you put it in your project root folder instead. Just the root of your submission folder. It's just easier for us to find. We'll be less likely to accidentally think you don't have it. So anyway, cool. All right, let's keep going. We got about 10 minutes, and we're gonna take a nice break. Where did my my lecture plan go? It's a mystery. Okay. Let's, next what I want to do is I want to briefly and briskly take you through 3 different concepts that are kind of core to Unity that hopefully will help you out in the early part of this course. So collisions and triggers is something that tends to trip up students understanding the difference between a collider vanilla version, a collider that is a trigger, and a rigid body, and what that component does for your game object. We want to go through input management briefly and talk about the different functions you can use. Input.getKey, input.getKey down, input.getKey up. And then we really need to go through coroutines, which is an extremely potent technology that will make your life much easier if you use them on this first project, but can be a little bit difficult to understand. So let's go ahead and let's start off with collisions. When it comes to collisions, there are basically 2 concepts you really need to understand: rigid body and colliders. As with many things in Unity, these are both components. these are two different types of components. We'll go ahead and take a look at them now. Okay, so you can see one rigid body down here. In fact, you used both of these two components in your tutorial 1 and tutorial 2. A rigid body, as you probably know, is a component you add to a game object that causes it to get physical properties. That means it has gravity, the force that constantly acts on it. It has acceleration, it has velocity, it has momentum. It can actually bump into things, right? If it has a box collider, which controls what actual shape the game engine considers your object to have as far as collisions are concerned. I have a challenge for you, chat. And maybe, besides the tutorials, this is your first big challenge of the semester. Are you up to it? I don't know. We'll find out. Okay, so what I'm going to do is I'm going to show you some situations. I'm going to ask you what's going to happen. Here, in this simple scene, we have a sphere and we have a box, two game objects, okay? And if you look at the sphere, it has three components on it. It has a transform component, it has a sphere mesh filter, and it has a mesh render. If that mesh filter is confusing you right there, you can think of it this way. It's just a component that is holding a batch of vertices, okay? So in this case, this mesh filter is holding the sphere vertices that the mesh renders, okay? The mesh render talks to the mesh filter, says, hey, what kind of 3D model you got? Okay, I'm gonna render that, all right? You get rid of either of these things and you won't see any visual representation of your object. Okay, then we've got our actual cube down here, our cube, right, which is just a rectangular prism. It's stretched out to look like ground, okay? And these are the components it has. Essentially the same thing, except instead of a sphere, instead of a batch of sphere vertices, it's holding a batch of cube vertices that the mesh render renders, okay? Okay, so I'm gonna go ahead and make myself tiny in the corner here, or I'm gonna go away. Okay, so here's the question. What is gonna happen when we run this game? And this is a question that not only preys upon, or not preys upon, but it challenges your understanding of how components work and make game objects do things in Unity, not just collisions. Chat, what's going to happen when we run this game? We got nothing. Both items float. They just stay in place. Both vibes. They're just vibing there in space. Bingo. Bingo. You got it. You got it. I can't get anything by you, chat. All right. That's what happens right there. A whole lot of nothing. Okay? Okay. So remember, a rigid body component gives a game object physics. A collider gives that game object an actual collision volume, okay? That determines whether it rolls like a sphere or maybe it rolls like a block. Here's an idea for you, chat. Here's a question I didn't even put in here. What happens if we give this sphere you know, everything has a collider on it, everything has a rigid body, so these things can interact. But instead of a sphere collider, I give it a box collider. What happens if I give this sphere a box collider instead of the sphere collider you might intend to give it? What would happen? What would happen? Would this sphere roll down a hill like you'd expect a sphere? It won't roll, it'll lie flat on its surface. That's right. You got it, Yumish Because it's going to be a box. The physics system will see this sphere as a box, whereas our eyes will see it as a sphere, right? Because it has a mesh render component on it, which draws the sphere vertices, but has a box collider component on it that tells the physics system, yeah, you should treat this like a box as far as physics are concerned. Okay, let's keep going. Too many tangents. We're not going to finish today. Okay, I made some changes here, chat. Can you tell? I made some changes. I gave the sphere a rigid body, and I gave the ground a rigid body. So what's going to happen when we run this? Both are going to fall. Bingo. There we go. They're both going to fall. Well, that's not good. Hey, chat, here's a question. Are these things falling, or is my camera going upward? The world may never know. they are the same from our perspective. Okay, so here's a question for you. I've made another change. Steak eater. Da, 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 da. Okay, so let's keep going. I've taken away the rigid body on the ground because we don't want them both to fall. We want the ball to fall onto the ground so we can do platforming, right? Okay, what's going to happen? Ball falls through the ground. Bingo. Well done. Well done. Now the ball. Okay. The ball has the rigid body, right? So it can fall. But we're missing a box collider on the ground. We've now added it, chat. Okay. The ground has a box collider. Okay. So now what's going to happen? We're going ghost. Wait, no, chat, no, it can't go through the ground. I added the box collider to the ground, right? How can it go through? You're right, chat, you got it. Okay, the ball still goes through because while the ground now has a box collider, the ground may have a box collider and be able to interact with things. However, the sphere does not. The sphere essentially does not exist in the physics system, at least as far as collisions are concerned, because it has no collider. It has no collision-related component on it. Okay, so here we go. I've added the rigid body to the sphere and the sphere collider to the sphere, and I've also added a box collider to the ground. What's going to happen, chat? Chat, what's going to happen? Okay, is this when it finally works the way we expect? Let's see. Yay! All right, good, very good, right? Okay, the ball can move and fall and has gravity because of its rigid body. However, the rigid body alone does not allow it to collide with things, so we give it a sphere collider. Okay, now it can collide with other colliders, and because of the rigid body, it can actually fall. The ground does not have the physics properties of acceleration, velocity, momentum, angular velocity. It doesn't even have gravity. However, it does have a box collider, so it does exist in the physics engine as far as collisions are concerned. So other things can collide with it, all right? And that's how it works. Cool, well done. So I have another question for you. Well done, chat. I have another question with you, and then we'll go ahead and I'll leave this with you, actually, because we're going to take a break for 5 minutes. What is wrong with this game? I'm going to show you the following game, and there's something horribly wrong with it, okay? And I'm hoping you can help me debug it. I'm going to give you a little, little help here, okay? So we got a rollerball here, and we're going to go collect this block up here, okay? Tell me if you notice anything wrong with how this works. Okay, we're gonna grab it and then, ugh! Oh, jeez. Okay, we're gonna grab this one, ugh! Okay, we're gonna grab this one and oh, I missed it. We're gonna grab this, oh, jeez. Okay, chat, did you notice anything wrong with how this collection is working? Ugh. Okay, I'm gonna let you ponder it for a little bit and let me know, and you can ask questions for the next 5 minutes, okay? And I'm going to turn on some choice music. Okay, see you at 1:35. I hope we don't get DMCA.
What a thrill, with darkness and silence through the night. What a thrill. I'm searching and I'll...
What's the difference between a kinematic rigid body and no rigid body at all? So, okay, a kinematic rigid body, as far as I understand it, still allows you to... It doesn't give you the physical effects of gravity, acceleration, angular velocity, or any of that. However, a rigid body is necessary for detecting certain things, such as collisions and trigger collisions, okay? So, if you take a rigid body and make it kinematic, it won't have the physical properties that you normally have, like rigid body, but it will be able to detect, for instance, a player moving into it or bumping into it. So I believe that's the primary use case. Yeah, kinematic is something you probably won't need to use for a little while. I think you can add things like velocity to a kinematic rigid body. No, you can. That's the opposite. So, a rigid body is something that a normal non-kinematic rigid body is something that has physical properties. So you can give it a velocity. If you take a kinematic rigid body, I don't think you'll be able to make it move. You'll have to use transform.position to warp it around. So, we have a few people in chat that are saying, hey, the problem with that last example we showed is that the physics have a collider. Sorry, the collectibles have a collider on them. But they must have a collider on them, right? Otherwise, the player can't touch them to pick them up, right? We need to be able to collide with something. However, there are two different kinds of colliders. There's the vanilla collider, and then there's the trigger collider. We'll talk about that in a sec when everyone comes back. Okay, that wasn't quite long enough. What can we get a good minute out of? I'm very tired right now. Maybe we can find something a little bit energetic. What's this one? Final Dreadnought 1, Battle Glacier. Oh, Jade Creek is really good. What game is this from? This one's gonna be hard. Popular indie game. Nice. You got it. Allure of Umich. This is the Freedom Planet game. Yeah, Freedom Planet has fantastic music. What's also cool is that the person who made that music is working on one of my games right now, which is really, really neat. I can't wait to show it to you. Okay, so let's go ahead and do students usually end up creating their own music for their projects? Usually no. Later on in the course, you can get a little bit of extra credit for teaming up with one of the PAT 305 students to have them make some music for you. But essentially every project will use a certain amount of open source music. And there's a lot of it out there, so this isn't necessarily a bad thing. Okay, let's keep going. So the issue with that last example was that we were using when I bumped into a collectible, it was killing my momentum. We were getting a physical collision and reaction from the ball hitting that cube, okay? And that's not something you want when it comes to collectibles. In games, it often feels much better to run through a collectible, detect the collision, but not have any physical interaction between the objects. You need to detect the collision somehow because you need to know if the player touched the coin so that you can increment their inventory, right? But you don't want to have the physical interaction occur. And so that's what we do. So here's what we had going. We're essentially using on collision enter. Okay? In reality, what we really want to do is we want to take that collider component, click the little checkbox underneath it near is trigger. What this does is this tells the collider that it needs to forego making that physical interaction happen. We still want to detect that these two objects touched each other, but we don't want to let any sort of physical interaction happen. When you do this, when you check this box, you need to actually change the function that you use to detect this and run logic based on that interaction. It needs to go from being an on collision enter to an on trigger enter, okay? And the actual parameter that gets passed in to tell you about the interaction goes from being a collision data type to being a collider data type, okay? This is a very common recurring pattern in Unity, and it has its pros and cons, but in Unity, there are certain function signatures that if you write them out precisely, they will get called at certain times, guaranteed, okay? One of those is the example of the start function that you've already seen and the update function, which you've already seen. If you put a start function with capital S, no parameter, in void return value into any component, it will get called by Unity automatically when that component is instantiated into the scene. Same thing with update, except it'll be called every single frame. Likewise, with on collision enter, if you have a box collider and I believe a rigid body on your game object, it will be called. And if you have that click that is trigger checked, then on trigger enter will be called. A very common issue with this is you forget to capitalize like the O or the C, or you have the wrong parameter coming in. That can cause Unity to decide it doesn't want to call that function, and then you'll wonder why your collisions aren't working. A really good way to test this is just put some debug.log into either of these functions when you first write them, just to make sure that the collision is being detected, your logic is running. Then you can decide what logic you want to have. Another example that's useful here, another thing to think about is many functions that are built in like this will come with a parameter. So in this case, a collision.other or a collider.other. This is essentially Unity's way of giving you more information about what happened. So you can actually use these data structures that get passed in to know, okay, I know a collision happened, but who did I collide with? How fast were they moving when they collided? What is their relative velocity? What is the exact point on which they collided? What is the normal that comes out of that point? That can be really, really useful stuff for implementing various features. Okay, cool. Let's keep going. Unity may seem out of first, blah, 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 blah. Okay, we already talked about this. The way you name things is very important in Unity. Okay. If you want to know what all the special function signatures are in Unity that can have some automatic response happen, if you do a search online, just Google Unity mono behavior, you'll see these. They're called messages in Unity. And you'll see there are quite a few of them. There's a wake, which takes place before start. There's late update, which is an update call that happens after everything else has had its update run. There is on became visible. So if you want to know when an object just entered the camera view, on became visible will execute when that happens. On became invisible will happen when it goes out of focus. If the player unfocuses the game window, on application focus will happen. Stuff like that, right? Okay. So blah, 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 blah. This is often used, this data getting passed in is often used to decide, okay, what did I contact? And if, for instance, you just touched a collectible, then you can turn that collectible off, you can increment a player score, stuff like that, all right? There are 3 functions. How do you get info on what object you collided with? We just went over that, right? So you'll have a function like this. and some parameter will be passed in. That instance right there, that object that gets passed in, will usually contain all the information you need to understand anything you want about the nature of the collision, such as what other game object did I just touch, okay? So there are three functions that are very interesting. It's this pattern you see throughout Unity. On collision enter, on collision stay, and on collision exit. So enter, stay, and exit are the differentiating keywords between these three functions. I'll go ahead and make my screen small. Oh, not that. There you go. And these are all very useful in different situations, okay? The first thing you want to know is if you know about these functions but you don't know what they do, you can always figure out what these things do by just essentially Googling Unity and then topic, or Unity on collision enter, Unity function name, right? And you'll find a lot of information. Here's an interesting question. What is the difference between these functions? So enter, as you might guess, this is a function that will get called when during the one frame in which two objects come into interaction with each other, come into collision. It will only execute during that one frame in which they, boom, contact. If they stay touching each other, then you will have the on-collision stay function executed every single frame in which they are still colliding. Boom, 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 right? And then when those objects separate and stop colliding, you'll have one frame in which on-collision exit is called. So here is the life cycle of these three functions. Okay, no function being called, no function being called, no function being called, no function being called, on-collision enter, on-collision stay, on-collision stay, on-collision stay, on-collision stay, on-collision stay, on-collision stay, on-collision exit. No function called, no function called, no function called. Okay? The reason you care about this is that certain bugs can show up if you use one of these functions but forget to use the others in certain situations. Okay, here's a scenario. Imagine for a second that you have a player character and an enemy character. When the player character touches on collision enter, you want to deal damage to the player, but you then want to give the player an invincibility period so they can't be damaged for a few seconds, letting the player run away, for instance. Okay? Or, maybe you don't do that. You just, hey, we're only going to use on collision enter. We're only going to use on collision enter, and we're going to deal damage whenever anyone touches another enemy. Okay? Well, as it turns out, you could prevent on collision enter from executing by hugging the enemy. Okay? Because, okay, the player and the enemy is headed toward the player. The enemy is toward the player. The enemy is headed toward the player. On collision enter, decrement their health. But then on collision enter doesn't activate again until they actually separate and come back together. So as long as the player hugs the enemy, they will never take damage from the enemy ever again. Okay? Is that crazy to you? It is. And it's a bug we see all the time on P1. It's not good. So what you need to remember to do is keep in mind that on collision enter will only execute when you first interact with something. If you stay interacting, it won't anymore. So you would need to also use on collision stay to decrement health for every frame that you're touching the enemy. You probably want to throw an invincibility period in there though, otherwise the players are going to freak out when they lose all their health in a split second. Okay, I had something like that happen in tutorial 1. Yeah, that can happen. Okay, we already talked about this. That parameter coming in is basically Unity's way of telling you more about the collision that happened. Okay, the event that happened. You can always go online. You can look up these data types. You'll find great documentation. Unity has fantastic documentation on all the different values you can get out of these data structures. Okay, you can know what collider you hit. You can know what contact points you hit. Game object hit, impulse, the relative velocity of the two colliding objects, all of it. Okay, so I have a challenge for you. What does this script here do? I love giving you these challenges, chat. You do a good job. Yeah, that actually does. The Sans fight has that. So the Sans fight has some objects that take away your health for every single frame in which you're colliding with them. That would be using the on collision stay. So that'd be accurate. What does this do, chat? What do you think it does? This is a really simple line of code, but it does a really interesting thing that you'll find in a lot of platformers that have sloped environments. So a platformer that isn't just blocks with solid surfaces always going up. Okay, while you're colliding, what is transform? So remember, the transform is the component that every single game object is guaranteed to have. It's at the top of the game object's list of components in the inspector, and it is the one that controls position, rotation, and scale. Okay, bounces you off instanting. Does it keep the rotation a certain way? Ah, yes. What this is doing is this is saying, hey, game object, whatever direction is up locally for you, it should always be in the direction of the normal of your collision. In other words, you need to rotate yourself so that your up direction, like your head, the top of your head is always pointing in the same direction as the ground you're touching. In other words, this is a way of rotating a character to angle themselves to be on the slope that they're on. Here's a GIF of what I mean, okay? This is a sloped and round platform that this player is on. As the player actually walks off to the side, this detects a collision between the player's feet and the ground. That normal vector, like in Physics 140, if you took that, goes out of the ground upward in a direction. The game says, hey, player, orient yourself so that your local up vector is pointing in the same way that the normal of your ground is. And this forces a rotation to happen on the object, which makes it look like it's kind of leaning downward as it walks down on a slanted slope. It's really, really cool. If you don't have that, actually, I lied. I'm not sure why I put this in here. Oh, yeah. If you don't have this line of code, your character just kind of goes rolling off. Right? It doesn't orient to anything. It's just randomly flopping around. So this technique is actually really useful if you want to do something like make a turret aim at a character, right? So you can calculate the vector that goes from the turret to the character. That's really easy to do. It's just destination location minus my location. That gives you the vector that goes from you to your destination. And then you go transform.forward or transform.right maybe. And you say, hey, whatever your forward vector is locally, right? If my body's a game object, rotating myself makes my forward vector, my hand, rotate as well. My forward vector needs to point from me to my target. That causes me to rotate and rotate continuously as my player runs around. That's a really good way to make a turret. It's super, super easy to do. Okay, and you get to avoid all the other rotation functions. So you just say, hey, just point yourself in that direction. I don't care how you do it. Okay, so that's essentially all I have for you now on the topic of rigid bodies and colliders. Feel free to review this lecture and this presentation when you get into Project 1, because one of the things you'll need to do pretty quickly is you'll need to get up to speed with collisions in your P1 milestone. You'll be following a tutorial to do that, though. It's not too bad. Okay, we got... I need to prioritize for us here, so we're going to skip input management. We're going to go to coroutines, okay? So, yeah, hold on to something, because this can get a little bit hairy. Okay, I'm going to show you like one of the most difficult things to make in Project 1, okay? So if you understand how to use coroutines to solve this problem, you're going to save like 5 to 10 hours, probably. Okay, let's take a look. It might surprise you. Okay, difficult sequential mechanics, room transitions. All right, go ahead and watch this. We're gonna watch this video. In fact, I'm gonna get rid of full screen here so I don't bug out here. Okay. Okay, watch how this room transition happens in The Legend of Zelda. Not this first one, but this one, okay? The player... My clicks are super delayed. Okay, hold on. Go. Okay, the player's going to walk into the dungeon. The dungeon is what you will be creating. Then they're going to walk left through this door, and a transition is going to happen. Move the camera, move the camera, move the camera, re-enable player controls. Okay. Now the player's going to walk back. Okay, disable player controls, move the camera, move the camera, move the camera, re-enable player controls. Okay? That sounds simple, right? It logically makes a lot of sense. You disable the player's controls, you move the camera, and then you re-enable them. But something makes this very difficult to implement in code with what you currently know. And we'll talk about that and why that's difficult in just a second. I want to show you in Metroid, you have the same exact thing you need to implement. Door transitions, a pain in the butt. Let's take a look. So Samus is running to the right here. She's going to shoot a door, and then when she goes through it, disable player controls. Move the camera, move the camera, move the camera, re-enable player controls. Okay? Disable player controls. Move the camera, move the camera, move the camera, re-enable player controls. Okay? Oh, how could this be difficult? Well, it has to do with how our programming languages tend to work. Okay? And the programming languages aren't super great at doing things that take time, where a delay must happen, where code must wait for other code to finish. The facilities in many languages for this are kind of lacking. And so let's walk through this really quickly in case you didn't get it through the examples here. The first step here, player hits a door trigger. In your Project 1, this is probably going to be an invisible trigger that the player hits, and this tells, this door game object has a component on it that might say like door. It's configured to point west. And so when the player hits this, it tells the camera system that, hey, we need to move one room west. Okay? And this is really easy to do. You already know how to do on trigger enter to detect something like this. We then need to disable the player controls. We need to disable the player controls, which is also pretty easy. If you want to just globally disable player controls, what you can have is you can do a public static bool. This is a Boolean that is easily accessible from every place in your code base. Public static bool, player controls enabled. And then within your player controls component, you just do nothing if that bool is set to false. So disabling player controls is super easy. Moving camera to the next room over 2.5 seconds is super hard. Okay, moving a camera instantly to the location you want is easy. Moving it over 2.5 seconds is a pain in the butt. Then re-enabling your player controls is super easy. You just flip that Boolean we talked about. Okay, and I'll prove it to you. On trigger enter, it's just, yeah, add a rigid body, add a collider to that invisible game object right there, and you're good. On trigger enter will work. You then, Google's blocking me right here, right? You can just have a public static bool and then just toggle player controls like that. Very easy to do as well. You did something similar with the bird scored value, I think, in tutorial 2. It's super easy to just flip that Boolean to false, but this part is a pain in the butt. Temporal mechanics spanning multiple frames can be tricky to implement because you don't really know how to execute logic over multiple frames. In C++, if you execute a function, all of that function will run. You can't pause that function, can you? Well, there are certain ways to pause execution of code, isn't there? You know about a couple of them, but they all won't work. You can use threads, right? You can block on a thread. You can launch a new thread. However, Unity does not allow you to use threads. Okay? When it comes to scripting in Unity, all scripts that you write in Unity will be single-threaded. That isn't to say that Unity is a single-threaded engine. It is not. But the scripting system it uses is single-threaded. It's a bit of a pain in the butt. Can you use something like thread.sleep? In C++, there's a function called sleep, where you can specify a certain amount of time, I think in milliseconds, that your code execution will kind of pause at that point. However, you can't do that in Unity because it will freeze your entire game. You can't pause one of your scripts, but let all of your other scripts run. It's not going to work. You're going to freeze your game for that amount of time. There's a function in C# that you might be, and in JavaScript, that you might be familiar with. It's called await. I think in JavaScript it might be called yield or something. I don't do a ton of web dev. But this won't work because Unity doesn't have a C# version high enough to support that kind of thing. So, what are we going to do? Well, okay. Let's take some code right here. Let's say we want to detect an on-trigger enter with the door, okay? And if the player touches a game object called door west, or at least it has a tag called door west, then we want to perform transition west. So we launch that function, okay? That function is right here. First thing it does is it disables player controls. Makes sense. It then tries to move a game object over time. Which game object does it want to move? It wants to move our main camera. Over how much time? 2.5 seconds. Okay, then after that's done, we want to flip our player control back to turned on, right? So we can actually control our character again. Now the big problem here, again, is that we can't create move game object over time. We can't write this function. Move game object over time cannot be implemented like this because when you execute a function, every line will execute in that frame. We can't just have it wait. We can't have execution wait for this function to conclude over the course of multiple frames while letting everything else run. So this line needs to pause execution of the function for 2.5 seconds and let other stuff run during the meantime. Thread.sleep will pause our entire game. We still need the camera to move, so we can't use it. Unity is single-threaded, so we can't launch another thread and just block on it. So a poor solution would be to make a state machine class, but that involves a ton of work, and that's what I used to do. It doesn't work at all. Now, Unity, the developers understood this was a problem, and they created a solution. It's an interesting one. It's called coroutines, okay? A coroutine is a way of making a function that can arbitrarily pause for a certain amount of time. And that's exactly what we need. And here it is. So here is a coroutine that is called awkward hello. Sorry, this is a component called awkward hello. When the game starts, it launches a coroutine. Okay, what coroutine does it launch? It launches a coroutine, which is a function called delayed hello. Okay, you get a coroutine when you put IEnumerator as the return value of delayed hello. Okay, this IEnumerator is essentially saying that this function will return a certain location within the function. Or in other words, it allows itself to be turned, the function itself gets turned into something you can think of as an array, and then it lets us step through that array and pause and not execute if we don't want to. So what do you think happens when we execute this function, chat? What do you think the output is going to be? Okay. Hello there will be said, but here's the question. How is it going to be said? If we were to play this right in our Unity editor right now and we just watched the console, what would we see? What would we see immediately? Yes, that's right. We would see hello there, okay? A super awkward delayed hello. What this yield return is doing is it's saying, hey, yield on this object. Okay, this object, you can think of it as a coroutine itself. It isn't, but you can think of it that way. That simply waits for 3 seconds and then finishes. Okay, so we get hello, 1 second, 2 second, 3 second, there. Okay. By the way, all of these pieces of code are available in the course repo. So if you want to play around and see what happens with all of these, you can download it as soon as you want. Okay, so let's keep going. So we have another example here. This one's a little bit more complicated. Chat, what do you think is going to happen? I'll give you like 30 seconds to think about what you think is going to happen here. This is a coroutine that calls another coroutine. It waits for a coroutine to finish. Coroutines, as it turns out, can wait for each other. This is an even more awkward hello than the last one. All right, chat, what's your guess? Bingo, you got it. The mailman came in first. Well done. It looks like a few of you got it. So this is a coroutine that calls another coroutine. Okay? When you're trying to break something like this down, you generally want to kind of look at each function individually and figure out what it does, and then figure out how that function is used by others. So let's go ahead and look at the inner function, which in this case is do some humming. Okay? Do some humming is a function that takes a number of notes as an integer, and it returns IEnumerators, so we know it's a coroutine. Other enumerators can wait on it, and it itself can wait. So what it does is it says, hey, while number of notes is larger than 0, it prints to the console, it decrements that number, and then it waits for 1 second, okay? And then if that number is still above 0, it just does and repeats this. This inner loop essentially does a hum and waits for a second. That's it. We do this 3 times. So if we go through this, we launch delayed hello as a coroutine. It launches as a coroutine, so it can yield and wait on other coroutines. It says hello, and then it decides it's going to wait on do some humming. How much humming? 3. 3 humming. Okay, 3 number of notes. Do some humming, then goes and then returns because it's hummed 3 times, and then we get to continue with this delayed hello coroutine, and we go to there. Okay. So essentially, we have created the ability to wait on logic, to have some logic span multiple frames, which is really, really important for us, okay? So here's a question for you, and this is a hard one. This is a really hard one. What does the following do? And I'm going to show you what it does, all right? This is a really useful coroutine that implements exactly what you made for exactly what we need for the room transitions. In fact, you can take this code, if you want to, from the course repo and use it on your project 1 to get a really hard part of the project out of the way just like that. What does this do? Yeah, so yield can only be used inside an IEnumerator returning function. So the compiler will tell you about this if you try and do it elsewhere. Okay. However, if you don't have yield return, you won't wait. So note that if we kept start coroutine in here, but we didn't have yield return, what would happen is this coroutine would launch the new coroutine immediately, but then immediately keep going. It wouldn't wait for it to finish. Okay? Okay. So I'm going to give you about 30 more seconds, and then I'm going to ask you what this does, okay? Hey, thank you for joining us again, Foxkilla. Good to see you. Does this code move the player to the starting position of the new room, so where they should start from the door? So sort of. This coroutine, okay, so this coroutine doesn't specifically move the player. If you look at it, there's no reference to the player in any of this code. But what there is a reference to is transform. In other words, this is inside of a component. Whatever game object you put this component on will be represented by transform. So this could move the player if we put it onto the player, but it could also move the camera, okay? So, yeah, why is it that code after a return statement can still be executed? Yes. So yield return is different from a normal return. Okay? So a return, as you've seen them so far in C++ and C#, ends a function, right? But a yield return does not. And why I don't know. It's a little bit unclear why the C# designers just didn't stick with yield itself, but that's what they chose to do. Yield return, you can think of it as a different keyword than a return on its own, okay? Okay, move the object, whatever game object this component is on, from initial to final position. Initial position is our current game object's position. Final position is 20, 0, -10, okay? Wait over the course of 2.5 seconds, wait for 2 seconds, and then move it back. Excellent. Tom W. Bush got it, nailed it, aside from one thing, this little input here, okay? This right here means that none of this will happen unless you press the space bar. So what happens is when the game starts, we launch this coroutine. Which coroutine? Wait for player input to transition. Okay, so we go into this coroutine, and we enter into this infinite loop. This infinite loop would normally mean a freeze, wouldn't it? However, this is not the case because this is a coroutine. This infinite loop gets down here. It comes down here. Oh, Google's blocking me. To this bottom line, yield return null. And that yield return null essentially tells it to wait until the next frame. That allows everything else to run. Because everything else is allowed to run, this infinite loop does not kill the program. It does not freeze the game. Okay, on the frame in which the player presses the spacebar, it grabs the initial position and the final position, and it runs a coroutine called move objects over time. This coroutine takes a game object, it takes its target component, its transform component, sorry, an initial position, a destination position, and then a float, representing the amount of time it's supposed to transition over. It then calculates a progress value that over time will go from 0 to 1. Over how much time? Over duration second time, which in our case is sent in, it's going to be 2.5 seconds. It calculates progress every single frame of the game and stays in this while loop until the progression has been completed. It uses that progress value that slowly goes from 0 to 1.0 to calculate what the new position is using a function called lerp. Lerp is a really cool function that allows you to get a 3D point between two other points based on giving it a number between 0 and 1. So if we gave this function lerp a 0.5, we would get a point that is halfway between initial position and destination position. If we gave it a 1, we would get destination position. If we give it a 0, it gives us initial position. It linearly interpolates, lerp, linearly interpolate, between these 2 points to give us one in between, all right? We then move our object to that position, and then we wait until the next frame. We recalculate progress, which will be different because time has advanced. Then as soon as we're done, we've waited the duration second time. This will be 1. We leave the loop, and we're done, okay? So press spacebar, we move our game object from that initial position we're currently at to the other position. Over 2.5 seconds, we wait for 2 seconds, and we move it back by just swapping these two positions, okay? And then we're done. Here's what that looks like. You press space, we move the camera. The camera game object, the main camera, has this component on it. Whenever we press space, we execute that coroutine, and we're good. So another thing I would like to point out that's really useful here is this move object over time. It's really generic, right? There's nothing hard-coded in this function that says, oh, it can only move the player. Oh, it can only move the camera. Oh, it can only move between these two positions. Oh, it can only move between two positions in 3 seconds, okay? All these things are passed in as parameters, which makes them really, really nice to use all over your code base. It's the beginning of a high-quality library. Because it's generic, it's fairly easy to understand. Hey, I want to move an object between 2 points over time. Pretty easy to get. And you can reuse it. While this math might be a little bit complicated to you, But if you write it once and get it working, then you can just forget about how it works, okay? Then you can just use it every place. Okay, so start thinking about a nice library. It's also public static, which means that you can use it from any place in your entire code base. You don't need an instance variable to use it. It's just a member of the class. So all you have to do anywhere is write coroutine utilities dot move object over time, and you're already using that function, okay? Cool. Okay, so you can see that it works really well. This is almost exactly what you need for Project 1, so I'd encourage you to take this code, okay? Take it, poke it, prod it, understand its power, and use it for other things. Okay, I have another example for you that might be of use. One of the things that can be very useful, particularly if you decide to do The Legend of Zelda, sometimes in The Legend of Zelda, you have to defeat all the enemies in a room before a door will open. Okay, well, how do you know what enemies are in a room? Well, you can do GameObject.find GameObjects with tag, and you can grab all the existing enemies in the current scene, throw them into an array, and then you can just check how long that array is. If it's larger than 0, you've got enemies that still exist. If it's smaller than 0 or equal to 0, then you don't have any enemies left, and so you can break out of the loop, or you can do something else, right? Otherwise, you can just continue going around the loop. Question, chat. If you had this loop, but you got rid of yield return null, what would happen to your game? What would happen if we removed this yield return null from this code? Bingo, Yumichvaru has it. It would freeze, right? So it would freeze because of this. As soon as logic enters this while loop, the only thing that the C# runtime knows is that you want to execute this loop. It's a normal loop, right? A loop is something you just go around until the exit condition is fulfilled. This has no exit condition. So it would just go around forever because it never knows when it should hand off execution to other stuff. As soon as it hits this yield return null, though, the runtime knows that should just wait. We're going to wait until the next frame, and we're going to let other stuff run, okay? So this is really, really important. This turns the infinite loop into an infinite loop that lets other stuff run so nothing freezes. Takes a break, you know, grab some tea. I got my own tea going on. Speaking of break, we're going to end in 7 minutes. And we're good. So we actually had a question up. From JJRP. That sounds like a commercial for old people. Okay, so why would the coroutine move the object back after 2 seconds? Are you talking about why this technically happens, or why I decided to implement this? So you would not want to move your camera back in Project 1. And that doesn't really make any sense. You move the camera from one place to another when the player walks through that door in Metroid and Zelda. In this case, I'm just showing you an example. So you can write complicated and interesting logic. You can imagine that maybe in the future you want to work on a game that has a cutscene system. And you want to be able to say, hey, I want my camera to go here, show this for a couple seconds, then go here, and then go back to where the player is, right? That could be very, very useful. Okay, so Yashmer said, okay, this is cool, but this is a while loop, right? So when does it end? It lets things take a break and lets other things run, but does the while loop ever end? And the answer is yes, actually, because this is a component, remember. And it will only be able to run its logic if it exists. So when you go to a new scene, or when this game object gets destroyed, this component also gets destroyed. This component gets garbage collected. And when that happens, none of its coroutines can continue running. And if this coroutine is stopped from running, then this while loop effectively has been broken. All right? So this while loop can break if there are no more enemies. It can break, but it can also break if the component that is running and managing this while loop is destroyed. So either way, it's not going to be a huge performance penalty. This might feel really dirty, but when it comes to performance considerations, think about this. Computers are really, really, really fast. And our games are not going to be on the bleeding edge of technology. We don't need the best graphics. We don't need the most complex simulations, okay? We're not working at a AAA studio. Not yet. And so don't worry about performance concerns until they are a concern. You can lose a lot of precious development time, which is what really matters in this class, by prematurely optimizing when you really didn't need to, okay? So a rule of thumb in this course is think about dev time first and performance second. If you can think of a pretty quick and easy way that's probably going to be relatively easy to get bug-free, write it that way, and then if that isn't performant enough, you can go back later and fix it up and optimize it. Because optimization, it tends to bring in a lot of bugs. And bugs tend to eat up a lot of dev time, and that's the thing that you're really limited on in this course, not performance. Computers are pretty darn fast for the designs that you're going to be trying to implement. So don't worry too much. Okay, I think this is another example. We don't care too much about this, but here's another example you can check out if you want to. Okay. Okay. Infinite loop. Why will the following code fail? I gave it away. Here's another example of a while loop that was put in without a correct understanding of what coroutines are, okay? So why will this fail, right? It feels like this should succeed. This will not freeze your game because you get into this while loop and then every single frame of the game, you are updating progress. Time advances, right? Right? And progress goes closer to 1, and then when progress gets to 1, you leave this while loop and you're good, right? Question. Why does this freeze? This is going to freeze your computer. Freeze your game. Okay. Progress, you're right. Progress will... Oh, no, that's not quite it. Progress will eventually become larger than 1. Right? And it will break out. It will eventually get larger than 1 as time.time gets so much further than the initial time that you timestamped that it's larger than duration second. It will get larger than 1. So that's not quite it. It runs more than 1 iterations per frame? Nope. Bingo, Yashmir has it. Okay? Other things cannot run until you yield control flow to other things. Okay? There's no yield within this while loop. And that means that the time system within Unity can never update its time. Which means that progress is actually never going to change because Unity can't see that time has changed. Time.time will remain the same value until the next frame. But the next frame is never going to come unless time.time moves forward. Okay? Because there's no yield here. If you stick a yield in here, then this code yields to all the other systems that are currently running, which means time.time gets updated, which means progress can become larger every frame, which means eventually we'll be able to end, okay? This and break out of this while loop. That's why, okay? Okay, so I think this fixes it. Blah, 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 blah. Cool, all right, good. Okay, I think that's all I wanted to show you, and we're right on time. I want to tell you about what we're going to do next on Wednesday, okay? So Wednesday is going to have one of my favorite lectures. This is the lecture that actually got me my job here. It's on composition, and we'll be playing a really cool game called Scribblenauts. Have you heard of it? Scribblenauts is an incredible game where it's a 2D game where you can bring any object you could think of into the game for use in solving puzzles if only you can spell it. Okay, so you write in a magic notepad, you spell out the name of an object like an apple, and it comes into the game. You spell out a name like a lawnmower, and suddenly it's in the game. It's amazing. And the question is, how on earth would you create this game with the smallest team of only around 50 people? Fifth Cell and Warner Brothers figured out how to do this with an incredible combination of inheritance and composition. We'll be talking about how they did this on Wednesday. Okay, so please look forward to it. We'll also be introducing Project One. Okay, and your first big part of that project, which is it's going to be that's the tight part of the semester, the hard part of the semester. So please prepare for it. Rest up a little bit, and enjoy the next couple of days. Okay, and then we'll see you on Wednesday. I'll stick around for like 5 minutes. And then I need to prepare for the 2:30 session, okay? We will see you then. All right. Take care, everyone. Thank you for joining us. And get some sleep. Why don't you? Okay. All right. What questions? Questions? Yeah, composition is so much fun when you get a grip on it. It feels really great to use. It can get you in trouble if you ignore inheritance too much. They are really complementary, but it is really cool, particularly with the power of the inspector. If you give a component to a game object in Unity, it's really easy to see what other components are on the game object. So if you're debugging stuff, if you have a component that is frozen, and you have another component that is reflective, and your game object is doing some weird stuff, you can go in and see immediately which components are suspect, right? It's got to be one of these two components. And you can actually turn them off and disable them and see if the nasty behavior goes away, and you're like, boom, that's it. That's the one that's causing our issues. It's really, really nice to debug. Can't sleep? Too many video games. What's everyone playing these days? I'm playing through Earthbound on the Super Nintendo. Anyone? What's everyone playing? When does the control return to the line of the yield return? Yes, on the next frame. That's it. Can we get started with P1 now? No. We pretty tightly control the amount of time that you have for every leg of P1, every deliverable. And part of this is that we need to give you enough work so that you must make good time decisions, and that includes eliminating certain tasks and just deciding you're not going to do them, and using design patterns and approaches in a smart way. But we also need to manage your rest and your mental state and your health. And part of that means giving you days off where you literally cannot be working on something in 494 because you don't have the spec to do it. So that's why we shield you from some assignments at certain times. The composition lecture inspired my type of P1 roll. What's up, danger? Fixed update only happens 50 times per second. You can actually change that if you want to. Fixed update occurs whenever the physics engine updates. The physics engine is kind of a separate part of Unity that isn't always in sync with the rendering and scripting part of Unity. You can make it 60 if you want, so that it's sort of in sync with the rendering. But physics can be an expensive operation to update, and so and many games don't really need that often, need to update nearly as often as the rendering does. So that's why. Why is there any way to update physics? Yeah, you can go into edit, and then you can go into, I think, project settings and physics. You should see a tab for physics in there where you can update it. League of Legends, we got people playing League of Legends, Hades, Ultimate, Counter-Strike Go. Those are, yeah, that's got a lot of longevity, those games. Crash 4, I'm so sad because the game apparently didn't sell nearly as well as Activision was hoping. So I hope that franchise doesn't go dormant, because I really like the characters in that series, and the gameplay is just supreme. It's just so tight, so tightly designed. It's so snappy. It feels great. If you haven't played Crash 4 and you like platformers, you got to grab a copy. Teamfight Tactics. Melee? Oh, just got Wolf added, okay. DLC, I think. Cyberpunk. Okay. I've heard that game's really pretty fun when you if you can get past the issues, technical issues. Raid, not 60 yet. Played it with Quash. Okay. People still playing WoW? Yeah. It's cool. All right, everyone. I'm going to sign off briefly so I can go get a quick break, and then we're going to come back and basically redo this all, okay? Maybe with a couple new stories. I don't know. Okay, see you then. Thank you all for joining us. Bye-bye.